Hello everyone, this is Priyanka. Today I'm going to explain about my midterm project, which is cloud-based PE malware detection API. Here we do have three tasks. One is to deploy the model trained for Lab 5.4 as an API endpoint on AWS SageMaker, and the other is to develop a Python client which takes an executable file, extracts relevant features, and retrieves classification results from the SageMaker endpoint. And third one is to test the client and endpoint with one malware PE file and one benign file from the test dataset and to demonstrate on the video. Now I'm going to explain how I implemented the project using AWS SageMaker. First and foremost, we have to create one notebook instance. And then after creating the instance, we must run the train model file in first. And then in here, we're going to install all the required libraries and going to unzip the data. And then we have to train the model. Uh, first, first thing to do is to split the data, try and test the data, and to run the model. And as an output, we are going to extract three different files, which are KMOS engrams and featureizer file and section model file. After extracting these three files, we are going to deploy all of them. Yeah. And here, for deployment, we've developed an inference.py script. This is going to be utilized by SageMaker to process the input we gave to the API. Here we have various functions. One of them is model function. And this model function, we're going to deserialize the fetched model. It loads the model from specified directory and returns the loaded model. And in the input function, we're going to process the input data sent to the model. If the content type of request is JSON, it passes the JSON request body and returns the input data. As well as we do have predict function. In this predict function, we're going to make predictions using the input data and the loaded model. It first processes the input data using the process input function. And then in the process input function, it pre-processes the input before passing it to the model for prediction. It extracts features from the input data, transforms text features using featureizers loaded from files, which are imports featureizer pickle and section names featureizer pickle files, and concentrates all features into a single sparse matrix. The process data is written. And in the output function, we format the prediction results before sending it back as a response. And we take the prediction result, converts it into an integer, and creates a JSON response containing the output and returns it. And here we're going to mention the requirement files. And thus here we're going to create a new directory and copy the files which we created just now, like our pickle files, and then zip them and to transfer them. And here we're going to write the inference script. After the inference script, after running the inference script, we're going to import all the necessary libraries to connect with the SageMaker. First and foremost thing to do after before connecting is to set up the Portal 3 libraries. After that, we'll be able to connect to the SageMaker. And for that, we require the ARN number, which is available in our notebook instance. And after that, we retrieve the sklearn image URI, which contains the specific framework versions as sklearn and the versions which we need to use and instance type. And then we import the zipped models in the previous cells. Here I've uploaded it manually, and then we have to create the model. While creating model, we have to mention the specific details such as which image URI we are using and the model data URL which we are using and the model ARN. After that, we'll receive few outputs as a model name and the model ARN. From this result, we're going to configure the endpoint with model name and the instance type which we are going to use. And then we create an endpoint on SageMaker where we give the name of which we just received. And then we monitor this code continuously. We have to check the status of the code. And then we also, in the end of the configuration and creation of the model, we'll receive an output where it contains the endpoint name and other endpoint details. And then here we'll test whether the endpoint is working or not. Here in our code, I gave the details manually, all the required inputs. And here we are testing it. The output is S0, which is in the JSON format. Here it is working perfectly. Now let's configure the PE client file. Here we're going to utilize the following libraries. After installing the necessary libraries, we will retrieve the IP address from Google Cloud. And this IP address will serve as our endpoint for invoking the script on the client side. We'll be processing the executable files as input and sending them to the API. This client-side script will be the backbone of our web application. To streamline the process, we are leveraging a pre-trained dataset for efficiency. This ensures that we do not need to train the model each time we use it, saving time and resources. Now, we'll write a file for invocation. So this script, we can interact with the API, passing our process to AXE files for classification. And finally, we will initiate a web application using Streamlit, providing an interaction interface for users to interact with the model effortlessly. And then when we run this, we will receive an URL to run our Streamlit application. For that, we need to give a required password. Our password will be the IP address which we fetched previously. Let me copy that. Here's our output, which is the Streamlit app. In this Streamlit app, I'm going to upload a file which is supposed to get us a binary. Yes, here's our result. The file which we upload just now is classified as a binary file. Let's also check our output, our classification results with the virus file. And let's see the output. So here we receive the output as malware. Like our model classified the virus file as a malware file. This is all. Thank you.